can you describe and explain how PCR can be used to amplify a DNA fragment? Now, PCR stands for the polymerase chain reaction, and we use it if we've got a small sample of DNA and we want to make lots of copies of it really quickly so we can study the DNA or sequence the DNA, for example. So 4 marks. First marking point will be given to you if you can kind of list all of the things that you would need to carry out the PCR. So for PCR, you obviously need the DNA fragment itself, which is kind of given in the question, so you're probably not going to need to say that. But as well as the DNA fragment, you're going to need primers, you're going to need the enzyme DNA polymerase, and you're going to need lots of DNA nucleotides. Because remember what PCR is, you're basically making lots of copies of the DNA fragment. So to make lots more copies, you're going to need lots more DNA nucleotides as well as the enzyme which makes DNA, which is DNA polymerase. Once you've got marking point 1, you're going to want to start to go through the cycle of PCR. Now, PCR is carried out in something called a thermocycler, and it basically just cycles through 3 different temperatures so that 3 different things will happen. So the first temperature will be round about 95 degrees Celsius that the thermocycler goes to. Now, you can give a range of temperatures. They would probably accept any temperature in the range of about 90 to 95 degrees Celsius. But the reason we heat it up to a really high temperature in the thermocycler is because that temperature will break the hydrogen bonds in the DNA fragment, okay? So you've basically put in the fragment that you want to copy, and then you heat it up to 95 degrees Celsius so the hydrogen bonds break and you'll get 2 separate strands. Next thing you're going to do is reduce the temperature, and probably to about 50 degrees Celsius, but again, they will accept a range, so anywhere between about 40 degrees C and about 65 degrees C would be acceptable. Now, the reason you reduce the temperature at this point is to allow the primers to anneal, or you can just say bind if you prefer. Anneal basically means to join, to bind. So the primers at that temperature will bind, and that will help to keep the 2 strands of DNA separate, and it will also mean that the enzyme DNA polymerase can now attach. So final thing, and the final temperature in the thermocycler, we're going to increase the temp again to about, I'm going to say 72 degrees Celsius, because that's what I learned. But again, they will allow a range, so anywhere between about 70 to 75. The reason we increase it to that temperature is because that is the optimum temperature for this type of DNA polymerase. Kind of on a side note, but in PCR, they use DNA polymerase from a bacterium that lives in hot springs, and that type of DNA polymerase has an optimum temperature of 72 degrees C. So we increase the temp to about 72 degrees C, or 70 to 75, and that will allow DNA polymerase to start joining nucleotides together. Okay, so it's actually going to start building the new DNA strands. It's going to start making phosphodiester bonds, joining one nucleotide to the next. Now, it was only a 4-mark question, but we can't really finish without just mentioning you do have to repeat this cycle many times, but it's really quick. You can repeat it many, many times, and by the end of a few hours, you can have thousands of copies of your DNA fragment, because look at what's happening. You're basically going to double the number of fragments each time you run through this cycle. So really quickly, you're going to have huge numbers of DNA fragments that you can study. So remember how to answer it, list what you need, go through the 3 temperatures, and for each of those temperatures, make sure to explain what is happening at that temperature. If you enjoy content like this, make sure to hit the subscribe button and click the link in the description below to join my biology course.